Hey there, everybody. It's Mr. Sheeline. Welcome to this video. We're going to be going over the circle graph activity with you today. We're going to be covering this data right here. So the two previous videos that you should have watched, the first one would have been the double line graph. The second one would have been the double bar graph. And now we're here with the circle graph. So again, this is the information we're going to be using right here. Okay. All right, so let's just get into making our graph. So just like the last few times, guys, this is going to pretty much be the same exact kind of setup. So I'm still going to walk through it just in case there's something that you still want to figure out, still something you still don't understand. So let's just do this. So put in the title. So first I need to highlight this, merge. We're going to put in US energy consumption in 2009. Okay. We're going to put in our energy source. And we're going to put in the quadrillion BTU. Oh, not butts. BTUs. Okay. Now notice though, remember, we can do this. So remember this would have been in the notes. We can do this. We can highlight the columns and we can go to resize columns. We can fit the data, but I'll show you what happens if you fit the data. If you fit the data, it's going to emphasize on the energy source, which may not be a bad thing. But I know for myself, I'm kind of, I get a little particular. I know for myself now when I'm grading it, not really, but I know if I'm creating it for myself, I get particular. So if we want to keep them the same, let's try it. The default's 100. So, okay, so remember, this is the default. So let's maybe try something like 150 and see what that looks like. That's actually not too bad. So let's just keep it to 150. And when we highlight both of them, it's going to put both of them at 150, by the way. If we just highlighted A, only A would be 150, whatever units they use in the size. But since I highlighted both, they're both going to be 150. So they're both going to be equal. It's going to look good. So I'm then going to pause here, and I'm going to fill in the rest of the information off screen. So I'll be back to see you guys with all the good information, with all the good data. So I will see you in a bit. Okay, so now we're back and we have all the information that we need. We're going to do the same thing that we've always done. Dress it all up, make it look really nice. Center everything. Nice. Okay. So we've got our energy source. We've got our quadrillion BTUs. We've got all these lovely numbers here. Now all we have to do is, again, do what we've done before. We're going to highlight our headers, and we're going to highlight all of the other data down here below. Insert, chart, and then it'll take just a second. Here we go. Now, I have to begin with saying this. Be very careful when you are creating any data table, or sorry, any graph. So the program can understand the context that here are names of things over here under energy source. Here are names of things. It probably, I'm guessing, also picks up the 2009 up here, so it's a year. That's part of their parameter. But more importantly, here's all the list of things, and of the list of things, here are the particular BTUs. Now, let's say that you don't want to express this as a circle graph, or let's say you were trying to express this as a circle graph, but let's say there's something that you put in that actually is going to make it look like this. That may look like a bar graph. Okay. It's very possible that a bar graph would come up. Okay. Now it depends upon how you're trying to express the data. Okay. Now, if the idea is to show, not compare the amounts, not per se like compare the amounts in a particular year, like this, because this shows me just that trend. It shows me the lump sum of the what's it called? Like a lump sum of materials used, but it doesn't tell me it doesn't tell me really what kind of percentage, what the amount was out of the total energy used. Like this, you could figure that out if you had all that info, but it'd be super difficult. However, but if we use the pie chart, if we use a circle graph, this tells us all the information we need to know as far as, like, say, a group number is concerned. So meaning, this is what I mean, a complicated way of saying this. The program is adding all these up and making a total. And that total is like 112 quadrillion BTUs. And then what it does is that it is then finding the percentages of these values here. And that's how you get the 1.6. That's how you get the 1.74. And by doing that, it supplies us with an image of a graph that tells us that within a given year, this was how the energy was consumed. This was how it was distributed. Okay. Coal was 17.9, natural gas was 20.9, petroleum was 31.5%, so on and so on. Okay. And this is probably what you want to, or in most cases, this is what you want to express if it's a single given year. Now, if you're comparing years with one another, you probably do want to go with a double bar graph, just because you're then comparing the years between one another. But since it's a single year, this is how we want to distribute our data. Okay. So, but again, be careful, because sometimes the suggested graph that they start you out with may not be correct. You may have to choose a line graph if they start with a bar graph. Okay. It's very possible, quite probable, actually. Okay, but let's take a look at this. So quadrillion BTUs is in the title. We don't want that. U.S. Energy consumption in 2009. All right, so the rest of this, because this is pretty much it, because I don't see anything else that's wrong, or at least anything that really needs to be altered, this is where big personal preference comes in. So let's say the 20, let's see here. I'm trying to see if I should be able to edit the 20.9. Maybe I can't. Oh boy. Bit slow here. So yeah, like I said, I'm trying to see if I can change the 20.9, if I can increase the percentage, but I don't think I can. But what you can do is that if, let's say, you misspelled natural over here, you can change natural, or whatever word you misspell over here, you can change it over here, and it should plop over here and change itself. Like, let's see. If I change coal, say I changed coal to cool, I think it should. Okay, maybe it doesn't. So anyway, oh, it does. Okay, so yeah, if let's say you misspell it over here, you can respell it, the right way in there, and it'll just change it for the graph. It won't change it in the data table. But anyway, so there's the title. Everything's distributed. I would say the only thing is, I thought I could change the percentages, but it doesn't look like we can. The other thing that we can change is if we click on the particular slices. Let's say, actually, this is a really good example right here, these two. So part of, making a line graph is that, or sorry, not a line graph, but a pie chart, a circle graph, is that you want to make sure that your readers can accurately read the little slices. And so you generally don't want to put cool colors next to cool colors. You don't want to put warm colors next to warm colors unless they're super duper distinct. So as an example, yellow and red are both warm colors. But because this is like a goldish yellow, and this is kind of a deeper, not so crimson, but just kind of a general red, this is fine. It's super distinguishable, these colors. However, this light sky blue and this tealish blue, that may be a bit of a problem. So we can choose whichever one that we want to change. Now, we got to be careful, though, and cognizant of the other colors in the wheel here, in the circle graph. and maybe choose a color that won't conflict with this little pinkish salmon coral in here, and won't conflict with this teal. Or we could choose the teal, but then we have to watch out for this color and then the orange. So since the teal is a little smaller, let's change the teal. So we can just, you click on it like any of these, you just simply click on them and it'll take you straight to those options, and we can change the color down there. So we're gonna touch the geothermal. And again, we want to choose a color that's not too similar to that sky blue and not too similar to that orange. But it is also not a duplicate color within the what's it called, inside our pie chart. Well, let's take a look at this magenta-ish kind of pink. It's actually not a bad color. It does conflict a little bit with the orange. I would say it conflicts a bit too much with the orange. It depends upon you. Let's try the lavender. Lavender isn't terrible. It is a cool color next to a cool color, but it's a darker cool color. Okay, so it isn't the end of the world. So we're just going to keep it at that purple. It's distinguishable. It's easy to spot. It's easy to differentiate. Another thing you want to watch out for, and this gets harder with the more it gets harder when you have more. In this case, like energy sources, when you have more independent, you have more independent variables. So, there's only so many colors on the color wheel, and you can make custom colors here, and it gives you this little screen, and you can make it whatever shade that you want it to be. It is limiting though, because so a good example, we've got a blue here and we got a blue here. Really, this blue, you don't want to have matching colors, and even these, like you've got a gold here and a yellow here. We should probably, darken one of them up a little bit. So let's maybe darken up, the one that's already kind of darker. Let's see, what do we want to make it? Let's make it a little darker. Maybe too dark. I bet that's exactly what it used to be. Let's see. Yeah, it was. Maybe make it a little, let's do that. Okay, so now it's super distinct. Okay, and then let's change this gold over here. Maybe let's change this gold to, just a little darker, and not that dark. Of course, that's probably what it used to be. Oop, not that. Don't do that. Come on. That's what it used to be. Now here's where we can go to custom, and we can just kind of drag it, keep it over here and just drag it down towards the black a little bit. That's not too bad, okay? Because again, the point is to distinctly see the different little slices. You don't want to confuse these slices up. So that's why we changed the colors here. Did we have to change the colors? Probably not. But it's not a bad idea if you've got too many conflicting colors, because you don't want your reader to think that two different variables are the same, or you don't want to kind of hide a particular color behind another one. Okay, so kind of like over here, like it's possible if this graph was small enough, you probably wouldn't really see this sliver here. Okay, so you just want to be careful. Remember, you want to put like cold colors, you want to alternate it cold to warm to cold to warm to cold. So you can look up what cold colors are, what warm colors are. You probably should have gone through that in art already. But anyway, again, just look them up yourself if you're that curious. But anyway, that is pretty much easy peasy putting together a circle graph. If you guys have any more info, or if you have any questions, make sure you ask me. If not, awesome. Again, you can subscribe to my channel here if you want to get updates when I upload videos, so you can maybe watch them ahead of time if you're that driven to do that, or just know that see when I upload the videos and maybe go to them when you're supposed to, when I assign this material to you. Okay. All right, guys. So that's going to be it. So thank you for watching this video. I'll see you in the next one. Have a good one.